everyone. In this video, we are going to discuss a very important concept called named entity recognition, which we generally term it as NER. So what is this named entity recognition? So now look at this. It automatically finds names of people, places, products, and organizations in text across many languages. So you can see here like people, places, products, and organizations. So what is happening? There is a big text or a paragraph. From that, if it identifies people, places, products, organizations, etc., then the task is called as named entity recognition. So NER is a form of natural language processing. That is, it is a form of NLP, which is a subfield of AI, artificial intelligence. So what do we do in this NER? We identify and categorize key information in text. So this key information is basically called as entity, right? That is why it is being called as named entities, right? So this entity could be any word or it could be any series of words that consistently refers to the same thing. So every detected entity is classified into a predetermined category. It is not very difficult. It is an easy concept and also interesting concept, right? So named entity recognition sometimes referred to as entity chunking, extraction, or identification. So basically, it is the task of identifying and categorizing key information from the text, right? So this is what you have to know. Let us try to understand how this NER basically work. So NER model is a two-step process. So the step one is detect a named entity. Step two is categorize the entity. What is entity? I have already told you, categorizing key information, right? Fine. So what is this? How can I understand this better? Detect a named entity, which involves detecting a word or string of words that form an entity. So each word represents a token. We all know that, right? So the University of Delhi, when you say this University of Delhi, it is a string of basically 4 tokens that represent one entity, right? Fine. So the second step is that categorize the entity, right? Categorize the entity. So here, what I try to say is it is basically not 3 tokens, it is basically 4 tokens, the University of Delhi, right? So these all represent one entity, right? So the second one is that categorize the entity. So this step requires the creation of entity categories. So let us see that what it is. So how do we categorize the entity in NER model? It could be person, it could be organization, it could be time, it could be location, it could be work of art, right? So when we say person, say for example, Mahatma Gandhi, it could be a name, right? Arvind is a name, Sundar Pichai is a name, right? And then when we say Google, basically it is an organization, MasterCard, Amazon or organization. And then 2016, 1424, 2 p.m. These are all examples of time. And Bangalore, Noida, Singapore, these are all locations. Hamlet, Guernica, Exelon Main ST. So these could be work of art. So this is something similar to that, right? Whenever we have a paragraph, from that it tries to extract the information, right? So basically it is information retrieval. So we can create our own entity category. Say, for example, I'm working on some other task and I want to extract a few entities, right? So as per the requirement of me, as per the requirement of my task, I can recreate or I can generate my own entities, right? So as well as we provide granular rules for which entities belong to which categories in instances of ambiguity or task specific ontologies, right? Fine. So what are the applications of NER, right? What are the applications of NER? So like I can tell you clearly that this can be suited to any of the situation which is a high level overview of a large quantity of text. So we will say at a glance, if we have to understand the subject or theme of a body of text, and we can quickly group text based upon the relevance or similarity, right? So one example, what I can say is human resources. This actually we use in most of the industries, or we use, say for example, I'm hiring two people, but I'm receiving applications from around 1,000 people. Now, how it is possible? Is it possible to go through all the 1,000 resumes and figure out like whom I am going to call for the first level of interview? That is not possible, right? So this could help us to speed up the hiring process by summarizing the applicants' CVs, or to improve internal workflows by categorizing employee compliance and questions, right? So the second one is about customer support. So sometimes we will be receiving a lot of trouble tickets, or the lot of complaints from the customers, and there could be lots of questions. So we will be able to apply filters by using priority keywords, right? And the next one is about healthcare. It is used to improve patient care standards, and it reduce the workloads by extracting the important information from lab reports, right? And the next one is about education, right? In education, what I can say is like it can enable students and researchers to find the relevant material by summarizing papers and archive material and highlighting key terms, topics, and themes, right? Fine. And even in case if you want to search for some historical newspapers, or like in case if you want to find out certain papers that is related to particular domain, you can use this NER, right? And then the next one is about content classification. So like we using this, we can surface content more easily, and we can gain insights into trends by identifying the subjects and themes of the blogs or the posts or the articles, or it could be news articles, or it could be newspapers, something, right? So the next one is about search and recommendation engines. It improves the speed and relevance of search results and recommendations by summarizing descriptive text, reviews, and discussions, right? So these are basically the applications of NER. So we may be getting a question in mind that how we can use this NER, right? So say, for example, you have a business or project that could benefit from NER. It is always better to start with NER because there are lots of open source libraries that we can get, like NLTK, Spacey, Stanford NER and all, right? So if we talk about this NLTK, Spacey, Stanford NER, each one has its own pros and cons. So we can't say that like a particular library is preferable for NER. So it has its own pros and cons. We need to produce a relevant labeled data set to train the model on, right? So what I try to say here is basically like we can create our own entity categories, as I told. So to learn what is and is not a relevant entity and how to categorize them, a model requires training data. So the more relevant that training data is to the task, the more accurate the model will be at completing the task, right? So everything depends upon the training basically. So once you define your entities and your categories, And then you can use these to label data and create a training data set. And that is basically the named entity recognition can do this for you automatically, right? And then we can use this training data set to train an algorithm to label our text predictively. So simple, right? So this is the introduction and the explanation of named entity recognition. How to do named entity recognition using Python, right? Fine. So now you can look at the first line of codes. I'm importing all the necessary packages like NLTK. NLTK is nothing but Natural Language Toolkit, which is a library and program for symbolic and statistical NLP for English written in Python programming language. And also it contains a text processing library for tokenization, parsing, classification, stemming, tagging, and semantic reasoning. And then from NLTK, I have imported this word tokenize, which is being used to tokenize the paragraph or the sentences into words. And then from nltk.tag, I have imported POS underscore tag, which is used for parts of speech tagging. And then from NLTK, import NE underscore chunk. Chunking means it's a process of taking individual pieces of information and grouping them into larger units, right? And then I have downloaded this maxent NE chunker, right? So this is the text I have taken. This is the text I have taken. European authorities fined Google a record $5.1 billion on Wednesday for abusing its power in the mobile phone market and ordered the company to alter its practices. So what I'm doing in the next step, I'm defining the pre-processing of this sent basically. So sent is equal to nltk.word underscore tokenize sent, and sent is equal to this nltk dot POS underscore tag sent return sent. So what I'm doing is I'm going to pre-process this text basically, right? So when I print out that, what is happening? Like you can see European JJ authorities, NNS, find verb, Google noun. So like basically it is being tokenized, and also it is doing the part of speech tagging, right? It is doing tokenization as well as the part of speech tagging. Then I am defining a pattern over here, and then from NLTK I am using this using this regex parser, and then for this pattern, right? So this is what I'm printing out, and this is the tree. See, I can show it in this form also, right? So what I'm doing now, from nltk.chunk import, I'm importing to basically now, and then from print import pprint, and then I'm just printing out all these things, right? Then I'm downloading all the words. I mean nltk.download words, right? So once I do that, I'm trying to do the chunking of this already tokenized and POS tagged words, right? So this is what I'm getting. But here you can see that Google is being tagged as a noun, right? Google is being tagged as the noun, right? So what I'm doing now, I'm trying to do also with the spacey now, right? So import spacey, from spacey import displacey, from collections import counter, and import en underscore core underscore web underscore sm, and then NLP equal to this, right? So this is basically the doc I have taken, and just I'm just printing it down. So you can see the tag as well as the description over here, right? So the first token of a multi-token entity, and this is an inner token of multi-token entity, and the final token of a multi-token entity, single token entity, non-entity token, right? And then I'm just trying to get the output, right? So once I do that, what I have done is, from BS4, I have imported beautiful soap, I have imported request, I have imported RE, and then I'm defining URL to string, and then just I'm trying to get this, right? So totally I could see that length is basically 158. Okay. And then what I'm trying to do is I'm trying to label it now. So when I label it, I'm getting output as person 81 and a random name. I'm saying cardinal 5, and then it could be like ordinal 1, and say product 2, date 19, right? So what I'm doing is now x dot text for x in article dot ents. So I am trying to get the most common, right? So here I could see that this is 32, this is 17, and Trump has appeared for 13 times. And then I'm writing other sentences equal to x for x in article dot sense and trying to print the sentence now. So this is what the sentence look like. And I'm using display C now, display C dot render and NLP str sentences 10, Jupiter equal to true, style equal to int. So now you can look at over here. This is basically the person, and this house is basically the organization. So July is being tagged as the date, right? So this is what we could see. If you look into that, you cannot see any other important entities, right? So these are the three entities we could see in this sentence. So in case if I look into as an image, like you can understand like a Mr. Suskok had testified before. So you can see that it is being tagged, right? Mr. Is being tagged, and this is being tagged, and had is being tagged. So this is what being given here. And then this is I'm trying to use all the above, like with the POS and Lima and all, and this is what I'm getting as the output, right? So then what I'm doing is I'm using dict of string x dot label for x in NLP, and then I'm trying to get that. I can get to know that this is basically a person, house is organization, July is date, right? So what I'm doing to what I'm trying to do the same is like help of this trying to print. You can see that here Peter Strzok name is there. It is being tagged as person. You can see that. And here there is another name, JJ Kirkpatrick, and that is also a person. And Adam Goldman is a person. Fired Peter Strzok is a person. Trump is a person. Michael is a person. So you can see that randomly. I will show you. I'll show you like wherever there is a name of a person. Okay, and then you can see that say for example organization, you can see that the New York Times, and right, so you can see that FBI, and no, like though you cannot expect 100% performance in any model, but it will do whatever is being possible, right? Okay, so this is what happened, and you can see that whenever there are weeks, it is being tagged as date, and 100 is being tagged in cardinal, 1 is being tagged as cardinal, over months is tagged as date, 2016 date, right? So this is what we are getting, right? So you can look into the second, we all know that, right? It is being cardinal, and army is being tagged as no, army is being tagged as organization. Clear, right? So this is how it is being done, right? So when we talk about named entity recognition, this is the most popular, no, most important questions in the interviews, because they will ask you to do like how do you proceed with the named entity recognition, right? So you must be able to do that, right? So basically it will try to tag a person, then it will try to tag NORP, NORP, which are nothing but nationalities, or it will also tag NORP, sorry, NOR. Otherwise, let me clear it up. Okay. So I can tell you that there are several things like what and all named entity recognition can do is it could be related to person. We know what is person, and it could be NORP, right? NORP is nothing but nationalities or religious or political groups. It could be FAC. FAC is building, airport, highways, and all. And then ORG. ORGs, companies, agencies, institutions, right? And then GPE, right? So GPE is countries, cities, states, right? And then LOC is nothing but non-GPE locations, and it could be product. Product in the sense it could be objects, vehicles, foods, etc. And event means it could be like hurricane storms and also like battles, wars, sports, events, right? And then law, right? Law means like named documents made into laws, and any language, right? It could be language, it could be date, and it could be time, and it could be percent, right? It could be percent, it could be money, it could be quantity, right? So money in the sense it could be monetary values, including unit. And when we say quantity, it is measurement as of weight or distance. And then ordinal, ordinal is first, second, third, etc. And cardinal, right? So these are no very simple, and again, like it depends upon no like your requirement. So basically, what words you want to, what entities you want to tag, that you can choose on your own. Accordingly, we can train the data and work on it. Hope this is clear to you. Let us discuss about text wrangling. So just we are going to look like how to use Python for text wrangling. So in all the machine learning models, we used to pre-process the data, right? So similar to that, even in NLP, it is really required to do text pre-processing, right? So let us try to understand that in detail, right? So what are the pre-processing steps, or what kind of wrangling we can do with the text data, right? So let us start it. So first I have imported NLTK. From NLTK, I have downloaded Punch, WordNet, stopwords, average perceptron tagger, right? Okay. So I have taken an example of text. Machine learning algorithms can help in converting text to numeric feature vectors, right? So when I execute this code, I'm getting the same output because basically I'm trying to get the output of text. So when I write dot lower, so let me clear all this output now, right? So that would be really interesting, I guess. So let me clear the output. So this is basically the text. So what I'm doing now is text dot lower. So what I'm getting now, you can see that in the previous line, you can see capital M, right? Machine learning algorithm. So that is converted into lowercase. Now, when I write text dot upper, I can convert everything into uppercase letter. Text dot title, right? Text dot title. So what I'm getting, machine learning algorithms can help in converting text to numeric feature vectors. So what is the difference here? Capital M, capital L, capital A, capital C, capital H. That is what happening because we have given title, right? So this is basically about the case conversion, right? So the next one is about tokenization. What do we do in tokenization? Let us see. So this is basically the sample text I have taken. Text processing, text pre-processing is a crucial step in NLP. Cleaning our text data in order to convert it into a presentable form that is analyzable and predictable for our task is known as text pre-processing, right? So import NLTK, NLTK dot send underscore tokenize sample text. So what is happening here? The first sentence is text pre-processing is a crucial step in NLP. And the second sentence is that cleaning our text data in order to convert it into a presentable form that is analyzable and predictable for our task is known as text pre-processing, right? So if I want to convert it into word tokenization, Now you can see that text is separate, pre-processing is another word, is another word, is another word, crucial is another word. So these are basically the tokens, right? Now I have used NLTK dot talk tokenizer, and just let me do that. Now again, what you can see is text pre-processing is a crucial step, right? So this is what we are getting. So now I have imported Spacey, and from Spacey I'm loading encode web sm. So what is that? So after that, what I'm doing is text underscore Spacey is equal to NLP sample text, right? So what is the sample text over here? Sample text is this one, right? So after that, what I'm doing, obj dot text for obj in text underscore Spacey dot sense, right? So now in the next step, what I'm doing, text underscore Spacey, right? So I hope this is clear, right? So this is what happening over here. The same thing we have done with the help of Spacey, right? So in case if I want to remove HTML tags and noise, so I have imported request and request dot get, and just I have written one URL dot text, right? So the next step what I have done is, in the next step what I have done is I have imported RE from BS4 import beautiful soup, define strip underscore HTML underscore tags text. So soup is equal to, this is what I have written the code. Now let us execute and see what is happening over here, right? So you can see that this is basically the this is basically present in that particular URL, and this is what I'm getting. So this is the start of the Project Gutenberg ebook, the Bible King James Book 1, right? So this ebook was provided by David Whitger, right? So this is what I'm getting, book 01 Genesis, right? So now if I want to remove accented characters, I'm importing Unicode data. So define remove underscore accented underscore chars text is equal to Unicode data dot normalize nfkd dot comma text dot encode ASCII that I'm asking to ignore, and decode UTF-8 ignore, right? So let me execute this code. And for example, I have taken I have assigned some accented text to A, and let me execute this. Now you can see that this is basically accented text, right? So now in case if I want to remove this accented characters, just I'm writing remove underscore accented underscore cars, right? So what is happening now? I'm getting the output as some accented text only, right? So import RE, define remove underscore special underscore characters, text comma remove underscore digit equal to false. So basically I'm making remove underscore digits equal to false, and then I'm writing pattern also, if not remove digits else this one, right? And I'm asking it to subtract sub that pattern comma text, right? So when I do that, so I'm taking a sentence over here. Well, this was fun, see you at 7:30, what do you think, right? So now in case if I want to remove all these special characters, remove underscore special underscore characters from this, yes, basically remove underscore digits equal to true. So now you can see that I'm getting only the text, I'm getting only the string, I'm not getting any special characters over here. So when I write remove underscore special underscore characters, now I'm getting the digits also. In the previous case, I have written remove underscore digits is equal to true. So I asked it to remove the digits, right? So that's the reason the digits was being removed, right? So hope it is clear, right? So this is what being done by these things. And then let us try to understand porter-stemmer. From nltk.stem, import porter-stemmer. So ps is equal to porter-stemmer and ps.stem. I have given some examples like leaving, leaves, left. So you can see that ps.stem leaving, then ps.stem leaves, ps.stem left. So what is happening now? I'm getting output as LEAV, LEAV, LEFT. So what does this stemmer do? This provides the, or this cuts this word and it is just reducing, I mean, it is just eliminating this ing and just giving me the output. So here the problem is LEAV doesn't have any meaning, right? So in case if I write LYING, I'm getting LIE, right? This is fine. When I write for strange, I'm getting STRANG, which doesn't carry any meaning. Sometimes what may happen is when we do stemming, it may lead us to, it may give us some word that actually has some other meaning. So those are the complications with the stemming. Now import NLTK. P is equal to NLTK dot Porter dot Porter stemmer, NLTK dot stem dot Lancaster stemmer that I have written in LS, and define simple underscore stemming text comma stemmer equal to PS, and then just I have written this function, right? So when I run this and I have taken, my system keeps crashing from yesterday, okay, yesterday, or crashes, okay. Presumably, we are not lying, right? Okay, so let me run this now. What I'm writing now, simple underscore stemming, yes, comma, stemmer equal to PS. My system keeps has changed into keep, crashing has changed to crash. From yesterday, presume we are not lying, right? We are not lying, so that has changed to we are not lying. So now simple underscore stemming, yes, comma, stemmer equal to LS. Now what is happening? My system keep crash from yesterday. So I think I'm getting the same other than this one, right? R is changed to AR. In case if I use lemmatization, what will happen? So in lemmatization, it will take the root word which have the proper meaning. So from NLTK.stem, import wordnet lemmatizer, WNL equal to wordnet lemmatizer, and help WNL dot lemmatize. So now you can see that what is happening here. Say for example, cars. Right now, car is changed to car. And when I try to lemmatize this boxes, I got the output as box. For running, I'm getting run. Ate, eat. This is brilliant, right? Because this is not possible with stemming. Ate is converted into eat. Then with the adjectives, saddest is changed to sad, fancier is changed to fancy. So the next one is about ineffective lemmatization. You can see that eight, fancier, fancier, and fancier, fancier, right? So what is over here? Like what I'm trying to say is like here I'm specifying that which whether it is a noun or verb, just I have mentioned over here. Now I'm taking another, usually we use this example in all the documents. Yes is equal to, the brown foxes are quick and they are jumping over the sleeping lazy dogs. It looks funny. I'm going to tokenize it now. When I tokenize it, it is getting converted into tokens, which means the words. Now I'm going to lemmatize that. So what is happening now? The brown fox are quick and they are jumping over the sleeping lazy dog. Now I'm using the POS tag. What I'm getting the corresponding tag for each and everything. Say for example, sleeping means sleep plus ing. Basically it is verb plus gerund, right? So this is what I'm getting. Even for jumping, we are getting the same, right? So this is what we are getting. From nltk.corpus, import wordnet.adj, right? So I am getting A, right? So define POS underscore tag underscore wordnet. And for this tagged tokens, I am doing, right? So when I do that, I'm getting for each and every case. What is this basically, right? We know what is what, right? So what is happening here? It is tagging with the POS, right? So you can see here, for verb, it is being written as V, and for adjective, it is being J, and adverb, noun. So everything is being denoted already here under this tag underscore map, right? So what are we getting now? I'm getting what I'm getting N basically, right? So that is what I'm getting. Sleeping is basically verb. Lazy is basically adjective, right? So this is what actually happening, right? Sorry, adverb. Lazy is basically what is that? Lazy. Where is that? It is showing it as A, right? So we know that, right? Okay, fine. So the next one is about lemmatized text. And here we are, no, for each and word tokens, we are doing it. When we do that, we get the brown facts. You can see that here, WNL dot lemmatize word comma tag for word comma tag in wordnet underscore token. So what is happening here? The brown fox R, right? So the R is converted into B. Quick and they are get converted into B. Jumping got converted into jump over the sleep lazy dog, right? So hope it is clear, right? So you can also try out something like this. Then WNL is equal to wordnet lemmatizer, and no, and here again I'm giving the lemmatizer now. So the same sentence, if I try to lemmatize underscore text of X, this is what I'm getting, right? The same thing, right? Fine. So this is what I am getting, right? Now the next one is that define remove underscore stop words. Text is underscore lower underscore case is equal to false. Stop words is equal to none, right? If there are no stop words in the sense here I have used English, right? If it is lowercase, what has to be done? Otherwise, what has to be done, right? So when I run this, then we write nltk dot corpus words English, right? So this is being I, me, my, myself, we, are, ours, ourselves, you are, right? So it is showing some stop words, okay? And then in case if I ask it to remove the stop word, now what I can see, previously it was the brown foxes, right? So the is missing, the is removed, brown foxes, or right, R is being removed because it is a stop word. Quick, jumping. So over is basically a stop word that is being removed. Sleeping, lazy dogs, right? So you can also try out that. So in case if you want to remove something specifically, you can do that, right? So stop underscore words dot remove the stop underscore words dot append brown. And in case if you want to remove underscore stop words, yes, the lowercase equal to false and stop words equal to stop underscore words. So what is happening now? Since I have asked this to do it, I'm getting the foxes quick jumping the sleeping lazy dogs, right? So hope this is clear to you. So this is a simple notebook which is clearly explaining about text wrangling.